welcome Gauss Maths Academy. Today's topic is statistics in our 10th class level. So in this statistics, first one we can take a central tendency. We can start here mean. So mean also we call as a average, and also we call as a arithmetic mean. Is shortly we can represent as AM, arithmetic mean. Okay. Next, in this we can take here ungrouped data. In this ungrouped data, mean actually denoted by x bar. Mean is denoted by x bar. So what is the mean here? Mean x bar equal to sum of observations by number of observations. For in ungrouped data, ungrouped data also we call as a raw data. Ungrouped data also we call as a raw data. So x bar is equal to this observations here, n observations. So x1 is one observation, x2 is one observation, x3 observation, and so on xn n observations. So we can represent here x1 plus x2 plus x3 plus and so on xn by n. So that is sum of observations by number of observations. How many observations here? N observations. So the formula is here. We write in a symbolical form. This is called a sigma. This is sigma in summation by using the symbol for sum. Sigma xi by n. That is a ungrouped data formula. We can use this one. So go for this grouped data. Grouped data we are having three methods. In this grouped data we can take here class interval, or this we can also here we are taking the tabular form x1, x2, x3 and so on xn. So corresponding frequency we represent as f1, f2, f3 and so on fn. So mean is denoted by x bar. Which method it is? Direct method. So the formula is sigma fi xi, sigma fi xi by sigma fi. So we can go for the product of fi xi, the summation of sigma fi xi by sigma fi. Next video I can explain this direct method explanation. So what is the here xi? Xi means we are taken as a mid value. What is the mid value means? Mid value is that average of lower limit and upper limit is called as a mid value. So lower limit plus upper limit by 2 we call as a mid value. Mid value also we call as a class mark. Mid value also we call as a class mark. Example 10 to 19, it is a open class interval. Class 10 to 19. So lower limit is 10, upper limit is 19. We can go for the average 10 plus 19 by 2. It is a 29 by 2. We can take calculation. It is a 14.5 is the median. Okay. Next. So next method we can take here assumed mean method. Assumed mean method. In this method, mean is represented as x bar. So what is the formula here? A plus sigma fi di by sigma fi. Here what is the meaning of A? Meaning of A here assumed mean among mid values. What about di? So di is we call as a deviations. How will find these deviations? di is represented as xi minus a. So what about the sigma fi? Sigma is using for sum, or we can use sum of frequency. We can represent as sigma fi. Okay, this is the total frequency. What is the formula? A plus sigma fi di by sigma fi. This is the first method, direct method. Second method formula is assumed mean method. Next go for this method is, see this method is step deviation method. Also we call as a shortcut method. So which is here three methods for this observation, that is a class intervals are low, class interval is a small, size is small, we can go for the direct method. So assumed mean method also we can use here. Suppose the class interval this values are large, we can use the step deviation method. Mean is equal to x bar. Formula is a plus sigma fi ui by sigma fi into h. What is the meaning of A? Already you know about A is assumed mean among mid values. A. What about ui? Ui we call here as here shortcut method. Ui is represented as xi minus a by h. Already we know xi. Xi is the mid value. Mid value how we will find? Average the lower limit and upper limit, that is called a mid value. Lower limit plus upper limit by 2 we call as a mid value. H means already know here class size. H is the class size. Okay, this is the formula for step deviation method. Next, go for this any one formula problem. See here class interval is given. In any problem when we can given here class interval, corresponding frequencies are given. So class intervals are 10 to 25, 25 to 40, 45, 40 to 55, 55 to 70, 70 to 85, 85 to 100. So we can here this is called a class intervals, class intervals. So in these class intervals, the here see here 10 this values we call as a lower limits, this values we call as a second values we call as a upper limits. The successive difference of these two successive lower limits we call as a class size. So 25 minus 10 is the 15 is the class size. 40 minus 25 we also get 15. 55 minus 40 also we get 15. Go for this is different successive upper limits. This is successive upper limit difference. 40 minus 25 also 15. So what is class size? The difference of two successive lower limits, otherwise upper limits we call as a class size. Class size denoted by h. So here h value is 15. So class interval is given, frequency is given. So for this mean we want to find mid values. How we will find? Already I can explain mid value here. Lower limit plus upper limit by 2.